ॲम्प्लिफायर म्हणून ट्रान्झिस्टरचा उपयोग कसा करता येतो त्यात आपल्याला शिकायचं आहे आणि त्याच्याबरोबर त्याचे कॅरेक्टरिस्टिक पण शिकायचे आहेत. सो लेट अस ओपन द बुक सेमीकंडक्टर डिव्हाइसेस. Transistor configurations. So there are three configurations, namely common emitter CE configuration, common base CB configuration, and common collector CC configuration. The common emitter configuration of a transistor is a connection in which emitter is common to input and output, is shown here, common emitter configuration. Then we have common base configuration where base is common to input and output, and common collector configuration where collector is common to input and output. The common emitter configuration, we will discuss common emitter configuration in some detail because it is most commonly used configuration. So how do you connect a transistor in common emitter circuit? So this is the common emitter configuration. We have a transistor, then the input is applied between base and emitter, and output is taken between collector and emitter. So this configuration is called common emitter configuration. So you can draw this circuit in your notebook. आत्ता नाही काढलं तर नंतर काढलं तरी चालेल, किंवा आता एकीकडे काढलं तरी चालेल ऐकता ऐकता. सीई कॉन्फिगरेशन किंवा कॉमन इमिटर कॉन्फिगरेशन. कॉमन इमिटर कॉन्फिगरेशन. Common emitter configuration. The common emitter or grounded emitter configuration, input is applied between base and emitter. So how will we describe this configuration? We will describe it like this: input is applied between base and emitter. Input is applied between base and emitter, and output is taken across collector and emitter, and output is taken across collector and emitter. Output is taken across collector and emitter. So this is common emitter configuration. The common emitter amplifier configuration to be discussed later produces highest current and power gain of all these transistor configurations, mainly because input impedance is low as it is connected to a forward biased PN junction. So if you look at here, this is the base, this is collector, and this is emitter. So base emitter junction is forward bias, base emitter junction is forward bias, and collector emitter junction, as you can see, it is reverse bias, because this transistor is NPN type transistor. So collector is N type, base is P type, and emitter is also N type. So you can see that the base, which is P type, which is connected to the positive terminal, and N type emitter to negative terminal. So base emitter PN junction is forward bias, and collector emitter, base collector is reverse bias. So like that it is there. In this type of configuration, current flowing out of transistor must be equal to current flowing into the transistor. So we get the equation of current IE, that is the emitter current, to be equal to the addition of IC and IB. So IE is equal to IC plus IB. That is, emitter current is addition of base current and collector current. As the load resistance RL is connected in series with the collector, current gain of common emitter transistor configuration is quite large. Current gain is called a current amplification, and it is defined as the beta ratio. So what is the beta ratio of this beta DC? That is the output current upon input current. Beta DC, and that is defined as output current upon input current. थोडक्यात current gain. Ratio of output current divided by input current. तो इसमें आउटपुट करंट कितना है? आउटपुट करंट इज IC, input current is IB, so it is the ratio of IC to IB. Similarly, the ratio of collector current to emitter current is known as alpha DC. Alpha DC is IC upon IE. So we can write IC is equal to, here we can write IC is equal to alpha DC into IE, and here we can write IC is equal to beta DC into IB. Correct. And we have one more equation, I equal to IC plus IB. So from that we can define the relation between alpha DC and beta DC. So alpha DC is IC upon IE, so we can write alpha DC equal to IC divided by IC plus IB, and if we divide everything by IB, it will be IC upon IB divided by IC upon IB plus IB upon IB. Means we are dividing here numerator and denominator of this equation by IB. IC upon IB is beta DC. So it is beta DC divided by, again IC upon IB is beta DC. IB upon IB is 1. So alpha DC is beta DC upon beta DC plus 1. Similarly, we can also write about the beta DC. Beta DC is IC upon IB and then we can write IC upon IB can be written as IE minus IC. Okay नाही, IB किती येईल? IE minus IC. Then if you divide entire thing by IE, it will be IC upon IE divided by IE upon IE minus IC upon IE, and that will be equal to alpha divided by alpha DC divided by 1 minus alpha DC. So this is the relation for beta DC. So this is the relation between alpha and beta. Like this you can derive. So the main two relations are like this. You have one equation IE equal to IC plus IB, then your beta DC is equal to IC upon IB and alpha DC is equal to IC upon IE. So from this equation you can derive this. Since the electrical relationship between these three currents is determined by the physical construction of transistor itself, only any small change in the base current will result much larger change in the collector current. Thus, a small change in current flowing in the base will control the current in the emitter collector circuit. Typically, value of beta DC is between 20 to 200, and for most general purpose it is around 100. That is, one electron will flow from the base terminal for every 100 electron between emitter and the collector terminal. So this is how the common emitter circuit is there. Then we write the common emitter characteristics, input characteristics and output characteristics. So for measuring input output characteristics, the circuit is like this. Again, you can draw this circuit now or you can draw it later. This circuit is similar to what we have drawn in the previous case. Only thing here we are adding the voltmeters and ammeters for the measurement of voltages and currents. So the common emitter characteristic, the heading here is common emitter characteristics, or we can write CE characteristics. CE characteristics. Input characteristic, variation of base current with base emitter voltage VBE is called input characteristic. So it is the graph between IB and VBE. Variation of base current base current IB with base emitter voltage VBE is called the input characteristics of common emitter configuration. Is called input characteristic. So what can we do for this? We change the VBE. As you can see here, there is a variable voltage source here. So we change the base emitter voltage, measure that base emitter voltage here, and take the reading of IB here using microammeter. So the input dynamic resistance of a transistor is defined as ratio of change in base emitter voltage and the resulting current. So this is voltage versus current characteristic. So the input resistance Ri, instantaneous, or you can say dynamic input resistance Ri, that is equal to delta VBE, that is change in input voltage, upon delta IB, change in input current. Change in input voltage upon change in input current. So how does this characteristic look? They are very similar to the characteristic of a forward biased diode. That means initially the current is low and then it shows a low resistance path. So similar to any forward bias diode. They are similar to any forward bias diode like this. So the current is in microamperes. This is 100 microampere. This is 50 microampere. 0 microampere. So this is current in microampere. Whereas the voltage, breakdown voltage is generally 0.7. So like that it is there. So these are the input characteristics, and this is the resistance for delta VCE constant. VCE constant, that means the source output voltage is constant. VCE constant. So these are the input characteristics of the transistor. Output characteristics are the ratio between VCE and IC. The variation of collector current IC with the variation in collector emitter voltage, they are called output characteristics. So these are the input characteristics. If you want to write about output characteristics, we can write that it is the variation of collector current with variation in collector emitter voltage. This is the collector current and this is the collector emitter voltage. So variations of collector currents with respect to variations of collector emitter voltage VCE. The dynamic output resistance for that matter RO is equal to delta VCE, that is change in collector emitter voltage, upon delta IC, change in the collector current. The base current IB is constant at this time. From the curve we can see that the collector current IC is independent of VCE as long as the collector emitter junction is reverse biased. Also the collector current is large for large values of base current. The output characteristics are such that the collector current, it doesn't depend on the collector emitter voltage. The collector current IC is independent of VCE when it is independent of VCE when collector emitter junction is reverse bias. As long as the collector emitter junction is reverse biased, IC is independent of VCE. The collector current is large for large values of IB when VCE is constant. So IC is directly proportional to IB when VCE is constant and ratio IC to IB is also very large. That is the current gain, beta DC. So how the characteristics look, output characteristic, they look like this. If you want to draw the output characteristics, they are like this. This is for different base current, IB, 10 microampere, 20 microampere, 30 microampere, 40 microampere. These are the values of IB for which we are finding the collector current for collector emitter voltage. You can write it 10 volt here. And this is in milliampere, you can write 10 milliampere here. So it is in milliampere, it is in volt. So the input output characteristics are like this. So the collector current is independent of VCE as long as the collector emitter junction is reverse bias. So this property of transistor, कौन सी प्रॉपर्टी कि जहां पे तुम्हारा कलेक्टर करंट बेस करंट के डायरेक्ट प्रोपोर्शन में है और फॉर अ स्मॉल बेस करंट यू आर हैविंग अ लार्ज कलेक्टर करंट is used in the circuit called amplifier. So we can use the transistor as amplifier. Amplifier is a device which is used for increasing the amplitude of alternate signal. That means we give the input and that input is a small in the magnitude, and for that small input we get a large output. एम्पलीफायर जैसे कि साउंड एम्पलीफायर होता है जो आवाज की इंटेंसिटी को इंक्रीज करता है. The sound is stored in the form of electric signal. So such electric signal can be given to the amplifier, and an amplifier can increase the magnitude of that signal using amplifier. So this is the circuit of amplifier. Again you can see it is same circuit. A typical transistor amplifier is a circuit in the common emitter configuration. You apply the input voltage between base and emitter. It's a common emitter circuit, So emitter is common to input and output. So input voltage is applied between the base and emitter. A DC battery VBE is forward biasing the base emitter junction. There is a VCE battery which reverse biases the collector circuit. A small sinusoidal input signal is superimposed on the DC bias. और ये superimpose क्यों करना पड़ता है? Because we always want the base emitter junction to be forward bias. तो जो भी सिग्नल है वो उस 0.7 वोल्ट के ऊपर होना चाहिए. That means your base emitter junction should always be forward bias. This causes the output voltage VO also to change sinusoidally. A capacitor is connected in the output circuit to block the DC component. A load resistance RL is connected in the collector circuit and output is obtained across the load resistance RL. So same circuit is there, common emitter. You can draw it now or you can draw it later, but it is actually the same circuit. Only thing here in that characteristic thing, we connect the ammeters and voltmeters. Here the input voltage and output voltage are taken. So transistor adds amplifier. It is connected in common emitter circuit. So small sinusoidal input is superimposed on DC bias. A small sinusoidal AC signal is superimposed on DC. You can see it here. This is your AC signal and this is the DC battery which keeps the base emitter junction forward bias state. Then base current IB and collector current IC will have this sinusoidal variation superimposed on them. So the collector current IC changes in accordance with base current IB. We know that IC is directly proportional to IB, only it is amplified by the factor of around 100. That gain can be from 20 to 200. This causes the output voltage to change sinusoidally with the input voltage. This causes to change output voltage with input voltage. So as the current is directly proportional, output voltage is also directly proportional to input voltage. Then this capacitor, it blocks any DC component which can be present in the output. a capacitor blocks any DC component in the output. So you get the AC signal, pure AC signal at the output. The output is taken across load resistance RL. Output is taken across load resistance RL. Let us discuss the working of the amplifier. V input signal is applied to the circuit. Consider the output loop. So if you consider the output loop, we get VCC equal to VCE plus ICRL. VCC, that is voltage between these 2 points, is equal to ICRL, that is voltage across load, plus VCE. So VCC is equal to ICRL plus VCE. Similarly, for the input loop, we have VBB is equal to VBE, that is this voltage, plus this IBRB. When some AC signal is applied, VI is not 0, and then we can write when AC input is applied, we have VBE plus VI, small input, that is equal to small VBE, that is AC VBE, plus IBRB plus delta IB, change in IB, in bracket RB plus RI. The change in VBE can be related to the input resistance and the change in base current IB. Hence we can write V input is equal to delta IB in bracket RB plus RI, and that is equal to delta IB RI, as RB is very small. The AC current gain beta AC is almost same as DC current gain, that is beta DC. We have in the output side we have VCC is equal to delta VCE plus ICRL. The change in the base current causes the changes in the collector current. This changes the voltage drop across the load resistance. So we can write change in VCC, that is delta VCC is delta VCE plus ICRL, and that is equal to 0. So we can write delta VCE, that is the output current, output voltage, is equal to minus IC into RL. The change in output voltage is this delta VCE, and if we consider only the magnitude, we can ignore the sign. IC can be written as beta AC into delta IB, that is your IC, into RL. So voltage gain is defined as AV, voltage gain of transistor is defined as output voltage upon input voltage. So we write it as VO upon VI, both are AC, and that is delta VCE upon RI into delta IB. And if you put the value of delta VCE there, then it is beta AC delta IB into RL upon VI into delta IB. Again, delta IB can be written as VI can be written as this RI into delta RB, delta IB, delta IB cancels, and finally we get voltage gain equal to beta AC upon RL divided by RI. Here the negative sign indicates that output voltage and input voltage are out of phase. We know that there is also a current gain which is beta AC. So we can also write the power gain AP, and the power gain is beta AC into AV. So here we have ignored the negative sign for the voltage gain to write its magnitude. So this is the voltage gain, current gain, and the power gain. This is voltage gain. Then the current gain beta AC is IC upon IB, small IC upon small IB in that case, or that is equal to small IC upon small IB, and this is power gain. So this is how we use the transistor as an amplifier. So only last topic is remaining, logic gates, that we will learn tomorrow.